Hi, I'm Micaiah, co-founder of Txtx, and one of our goals with Txtx is to bring the efficiency and the security and the confidence of deployments that are in the Web 2 space with tools like Terraform. We want to bring that to the Web 3 space. And so we are introducing smart contract runbooks. These runbooks can help with your on-chain deployments and operations. And specifically, there's some great use cases that help when managing contract deployments across multiple chains. And so we're going to demonstrate that today with a EVM runbook that we can deploy our contracts across multiple EVM compatible chains. So let's take a look at our runbook here. We have, I'll start right here. So we're declaring our EVM add-on and we're setting up some network parameters. We have a secret key signer here. So all of our transactions will be signed with this signer that we're naming deployer, and we're providing the mnemonic here. This is with our manifest file where we have some constants set up. And we have an action to deploy a contract using the create to opcode. So this will give us a consistent contract address across all of our chains. So for that, we can use this get contract from Foundry project. And we're just providing the name of our contract, which is simple storage. We can say who signed the transaction and a salt that's used to generate the contract address. And then finally, we can output the contract address that's generated. And so this whole runbook will be run once for each of the flows we have defined. So we're going to define a flow called Sepolia, where we set up the chain ID of our chain and the RPC URL. And so we will be deploying this, running this deployment on the Sepolia chain. So I can go here, I can run txtx run deploy -u, and it is going to deploy my contract on Sepolia. And it's waiting for the block to be confirmed. There we go, we have our contract address. Now, if I wanted to add another chain here, you see I have this predefined flow, so I can just uncomment that. I can add another flow. I'm calling this one Arbitrum Sepolia. I've got Arbitrum Sepolia's chain ID, the RPC URL. So adding a chain is as simple as just adding another flow. So I can redeploy again. We'll see, we manage a state of your past deployment. So we can see that there's a new chain to synchronize. Do you want to continue, yes or no? So now we're deploying this to Arbitrum. Adding any number of chains, as long as they're EVM compatible here, since we're using the EVM add-on, is as simple as just providing a new flow. So now we've deployed both to both chains. I can also go to the contract, say I want to update my contract. I'm going to change UIT 216 to UIT 256 here. I'll run a forge build to recompile my contract. I can deploy again. And we see a diff of what has changed in our contract. And as a result of that, what actions are going to be re-executed. So on Arbitrum Sepolia, we're going to re-execute these. On Sepolia, we'll re-execute these. Yes, so now we're going to deploy to both of these chains. While that's running, I can show you another runbook here. So for this one, we're going to create a signer. We're calling it caller because we're going to do some contract calls. And this time we're using a web wallet. So we're going to be able to sign in a supervised mode in a web UI. We can say what address we expect to connect, what wallet address. We can get our contract from the Foundry project. We can just calculate using the create to opcode what the contract address is. So we know what contract we're calling. And we can have an editable input that the user can adjust on the fly. And then here we can do an ETH call to get the value in our simple storage before, and we can do it again after. So we have our value before and after our contract call, and then we have the actual contract call that we'll be signing. So we're providing the contract ABI, the address, the function name, and the values. Providing the ABI here allows us to do some type checking just to help you be able to provide the function name directly instead of the 4-byte signature, and do some type checking on the data that you input. And then finally, we can output the data from before and after. So if we want to run this, we can do txtx run call. So now we can see that this is running in our local host. And so here we can provide the public key by signing a message. So we can see that the correct wallet is connected. We can see our balance. We can start the runbook execution. So we'll see here the contract that we're calling, and then also the number that we want to store in the contract. So we can just put whatever we want here. Validate that. We can see the address of the deployed contract, and we can see our account nonce. We can see the cost, and we can see the transaction here that we're going to be executing. This is the RLP encoded data that's going to be sent. You can send that transaction. Now we'll wait for that to be mined. Now we can see the value before it was empty, and then after we have 21C. So this is that 540 that I set, but hex encoded. So we have used Txtx to deploy our contracts to multiple chains and to synchronize our deployment state across those chains. And we have used it to manually sign transactions in the browser so that we don't have to copy and paste keys to do any of our operations on the contracts that we've deployed.